Alright, so I'm going to go over something very briefly with least common multiple that will hopefully help you. We've already talked about how you can find the least common multiple using the TI Inspire. If we press menu 2, 4, and type in two numbers at a time, we can easily do that. Now, how does that help us? Well, when we're doing monomials, that helps us through the fact that when we do the monomials, we can get rid of these type of things and we can say, okay, let's find at least a number. So when we're working with monomial least common multiples, then we can use this to find, like, say, any other type of example. So if we want to take something very simple like this, then we can do the menu 2, 4 on the calculator, and it'll come up with the LCM, and it'll give us 6 and 15. And it should come up with something like, let's see here, 30. Okay, then we would put that answer, 30 and 9, and it would give us 90. So then from there, we could go, okay, so we know 90, and then we can look x squared y to the fourth, and that is it for monomials. Very simple and very easy. Okay, so you can see here, 65 x to the fourth y, 10x squared y squared, 26 y to the fourth. Again, if you do the menu 2 for LCM of 65 and 10, and then that should give you like 130, and then do like, say, 130 and 26, then you would get that 130 is the least common multiple for all three numbers. Okay, and from that, we then look at the variables. X has the highest exponent of 4, so that's the one I'm going to put. Y has the highest exponent of 4, and that's the one I'm going to put. So again, fairly simple. You can see how they work and kind of go from there. Last example, 11 and 18 probably gives you something like 198, and then do that with 20, and you would get 1980. M to the second and N to the fifth. So again, you just look at the variables, and that's fairly easy. So monomial LCMs are fairly easy. Now what about polynomial? Okay, so for the polynomial LCM, we want to factor each polynomial. So this comes back to you knowing your your factoring capabilities, and then use each factor the greater number of times it appears as a factor. Okay, so that means everything gets used. It's just you go with the one that you see the most of. Okay, so to remind you of some of the rules. So to remind you some of the rules, don't forget you want to first try to see if you can factor out the greatest common factor. Then it should hopefully be in a quadratic that you can say, like, okay, if it's normal, plus plus is plus plus, minus minus is, or minus plus is minus minus, plus minus is plus minus, minus minus is minus plus. Remember, the top ones we add, the bottom ones we subtract. If you have x squared minus a number, just x squared minus a number, don't forget that's x plus the square root, x minus the square root. So let's look at an example. Okay, so the first example we have, or in this example we have y to the fourth plus 8y cubed plus 15y squared. Okay, so you can see in each one of these we have a y that we can take out. We actually can go with that lowest exponent, y squared. And that leaves me with y squared, because if I take out 2 from 4, I get left with 2, plus 8y plus 15. Now this is a quadratic that we can factor and say y plus, two numbers that multiply to give you 15 add up to 8, 5 and 3, and now that one's completely factored. Then we go to the other one, y squared minus 3y minus 40. Well, that's a y, and minus minus is minus plus. So I can say, okay, y minus, and see, two numbers that multiply to give me 40, subtract to give me a 3, 8 and 5. Okay, so then that tells us that that's completely factored too. So again, if you go based off what it says for rule number 2, then you go with the greatest amount of factors that each one appears. I always like to put the common one first and then go with the others. But if you go with this idea, you've got, okay, so we can see that y plus 5 appears once. Then we've got this y squared, y plus 3, and a y minus 8. So we're trying to get all of them, but again, if they appear together in each one, then we only have to write it once. Okay, so let's look at another example. Okay, so I have a 4a squared minus 12a minus 16 and an a cubed minus 9a squared plus 28. Here I can see that all three numbers here are divisible by 4, so I'm going to factor out a 4 and say a squared minus 3a, notice that I'm dividing everything by 4, minus 4. And again, let's factor this. Minus is a minus plus. So I need two numbers that multiply to give me 4 and would subtract to give me a 3, which would be 4 and 1. Okay, that one's completely factored. Now I'll go to the other one. Minus plus is a minus. So I'm now looking for two. I was getting ahead of myself. Let's look. There's a common factor here. Each one of them has an a, so I can take out 1a. That leaves me with a squared minus 9a plus 20. Then I can go to a minus. A minus plus is a minus minus. So I'm looking for two numbers that multiply to give me 20 and add up to 9, which would be 5 and 4. Okay, so what do they have in common? They have an a minus 4. Okay, I've taken care of that. Then I can put here, like I've got the 4 and the a, and it doesn't matter the order that you put these in. And then an a plus 1, and an a minus 5, and that is the answer. All of that all together. And there you go. So these are, now again, remember, this is setting us up for how we're going to do adding, but again, hopefully this makes things a little bit simpler for you. All right, and that's it for today. Thank you so much. I hope you all enjoy this.